I would like to express my great thanks to organizing committee for the possibility to participate in this very important meeting. The topic of my talk refers to development of analytical methodology in frame of green chemistry conception. Everybody knows that mercury is the most hazardous element which falls into environment due to natural and technogenic processes and undergoes there in two different physical-chemical processes such as evaporation and precipitation and some others, and also to chemical transformation through the reaction of redox reactions and a very important process of methylation in the presence of bacteria and organic matter. It is known also that for mercury, permissible concentration in water is very low at the level of ppt, but as for solid samples is sufficiently high. Despite the variety of the chemical compounds of mercury in environment, some of them are of great importance. Among them, mercury in the oxidation state of 2, the most stable inorganic compound, mercury sulfide, and the most toxic compound, monomethylmercury. As for elemental mercury and dimethyl mercury, they are volatile and are mostly concentrated in atmosphere. As for toxicity, the monomethylmercury is the most dangerous for living organisms. It is obviously that there is a necessity to monitor and control not only the total mercury content in environmental samples, but also mercury species. In worldwide practice of mercury speciation, very complex schemes are usually used, which includes the critical stage of sample pretreatment. This is very important because during this process, for isolation of mercury species, they may transform to each other and may be also lost. Therefore, to prevent this stage of sample pretreatment looks very attractive from the point of view of analytical chemists. There is a method based on the thermal evaporation of mercury species from solid samples, but normally it has been used in analytical practice for total mercury determination. There are a few examples of this approach. Application for mercury speciation in some solid samples, mainly rose. And nobody tried to identify the methylmercury. There are some literature publications concerning this problem. And summarizing the situation in mercury speciation using thermal release technique, I may say the following. First of all, it has been established that the temperature range for mercury compounds are close to each other and very often are overlapping. The temperature ranges are also strongly dependent on the matrix composition, and therefore the temperature range of the species release may be changed from one object to another. The available data rather demonstrates the possibility of identification of virgin formless mercury than the determination of mercury species. This conclusion determine the topic of our The aim of our work to develop the assay to determine the most essential mercury species are taught before in solid sample with a different matrix using the combination of thermal release with atomic absorption detection. I may say that this approach is in compliance with 11 principles of green chemistry, because the main goal of green chemistry is to prevent the production of pollution during products manufacturing, but we may also produce some contaminants during analytical procedure. And when we try to specify the chemical forms of different elements, we normally use the previous stage. For example, for solid samples, the previous stage of these chemicals isolation using different compounds and very toxic, sometimes very toxic. Therefore, we also must avoid the generation of hazardous waste in analytical procedure too, and it would better to do it in real time. In our work, we used the well-known mercury analyzer, which is produced by Russian company OMICS, and it is oriented for the total mercury determination without previous dissolution of the sample. This instrument was slightly modified by the use of device for dosing unit replacement inside of the atomization section. The idea consists in the release of the sample, release of the mercury species during the replacement of the sample through two sections of the atomizer. In first section, the evaporation of the species takes place, and the second, the complete digestion, leading to the formation of elemental mercury, which then are transformed to analytical cell, and the atomic absorption signal is measured. This is worked in a closed system. Therefore, no mercury may penetrate into environment. The formation of analytical signals include three main process I told before, the successive evaporation in first section, where the transformation and partly complete dissociation occurs, the transportation of the species into section 2, where the complete atomization takes place, and transportation of elemental mercury into analytical cell and the measuring all the analytical signal. The simple thermogram is presented on the slide, and you may see that a baseline separation have been achieved for mercury 2 compounds and monomethylmercury. It is very important that the temperature range for mercury 2 compounds, oxide and salts, is the same independently of their nature. And unfortunately, the baseline separation was not achieved for monomethylmercury and mercury sulfide. But we used the traditional ways of this not separated peaks treatment to get the results. There were some two important problems. The first, the absence of correspondence between physicochemical properties of the species under investigation and for mercury 2 and the mercury sulfide. And the other problem is the influence of the matrix composition on the parameter of the thermopeak. But this problem was very successfully solved by the use of traditional analytical approach based on the dilution of the sample with inert material. And we tested different materials, and the most appropriate results have been produced using aluminum oxide in a corresponding ratio. These experiments were carried out using the sample with organic matrix as plankton and sediment as the sample with inorganic matrix. And then the conditions of the analysis were optimized with respect to flow rate, the flow of carrier gas, sorry for my Russians, and for heating rate. And in this optimized condition, the thermogram have been done. You may see the model mixture of mercury species and the same mixture spiked with each of the ones. As for the problem concerning the absence of the correspondence between physicochemical properties and the parameters of thermopeak, this question was answered only for mercury sulfide. It has been shown using infrared spectrum that during this process, transformation of mercury takes place and the formation of mercury oxide takes place. As for monomethylmercury, there are no these discrepancies, but as for mercury 2, it is not impossible to explain just now. As a result, the assay have been developed and the accuracy have been confirmed using certified reference materials of different nature and using intercomparison of the results by independent methods. The main advantages of the developed assay consist in the absence of the sample dissolvent stage. I told earlier that it is a critical stage for the erroneous results. Therefore, the data which presented in the literature are very often contradictory. And the easy of operation and commercially available instruments are present. But as for our perspective study, we try to construct the atomizer of new type, which permits us to stop the process during every species release. We did it on the example of very complex sample and realized the separation of mercury sulfide and mercury complex with cysteine. But it is a future perspective study. You may see that among the methods which are used in worldwide practice, our method is the most simple in realization, but as for detection limits, they are not too good, but they may be decreased due to the use of a large amount of the sample. But it's necessary to be very attentive to separate the signals. The developed assay have been applied to the study of mercury transformation in tailing impoundment of gold mining in Siberia, Kemerovo region in Russia. The technology in this mining, the cyanidation technology was used to extract gold. And the original ores were sulfide, and among them mercury sulfide was present. The residual matter undergoes to oxidation. As a result, mercury release into environment occurs. The typical object we investigated were the matter of sulfide waste, very acid drainage flow, and man-made swamp. It has been shown that mercury distribution between the species, methylmercury is marked with red, depends on a lot of factors, but among them the most important are the concentration of mercury and the organic matter content in pore water. But there is not too simple, because the mineralogical composition of the dry material of the tailing also influence efficiently on the species distribution and formation. There is a correlation between the distribution of mercury, between the species distribution, also correlate with the redox potential, pH, and organic matter content. As a result, it has been shown that the predominant mercury species in the solid matter of this impoundment is this tailing are mercury 2 and monomethylmercury. And the formation of monomethylmercury takes place in porous solution of this solid matter of tailing, because the conditions which are presented here are the most favorable for the methylation, chemical methylation process, not bacteria, but chemical methylation process. But another, this conclusion is not mercury sulfide, but coming to conclusion, I may say that the developed method may consider as a practical and reliable technique for direct speciation of mercury in solid samples, and it demonstrates significant advantages in comparison with those used in worldwide practice, because the sample pretreatment stage may be excluded. The method provides the detection limit at the level, absolute detection limits at the level of less than nanogram, and satisfactory relative standard deviation. And this method permits us to study the mercury transformation in contaminated region. You may see the photo of this instrument and part of our team. And in conclusion, I would like to say that let everything we do will save our nature. Thanks for your attention.
All right. Any questions? Do we have any questions? Okay. We're done.
Yes. I have one question. Is that amount of mercury which you have shown there in your tables, is that a common value in such an environment, or are you aware that there are regions with even higher mercury values in the environment?
You mean the tailing impoundment? Yeah. But yes,
okay.
it is very dangerous for our environment.
Okay.
There are a lot of places in Siberia which are very contaminated with mercury.
And places all over the world, do you know, are there intense differences in the mercury content?
I think, yes, it depends on the age of the tailing, and depends on the technology applied in this.
Okay.
Excuse me, one question. One question. In your exploration of the different sites and looking specifically at the methylmercury, have you had any work cross-disciplinary with microbiologists who follow essentially the microbiota of the site? The reason I'm asking this is because I believe the methylation of mercury comes from methanogen activity, and that could be easily detected by microbial methodologies.
I agree with you, yes. Yes, you are right. The process of mercury methylation normally takes place in the presence of bacteria, but as for our experiment in tailing impoundment, we did not studied the bacterial composition, but because the mercury species content correlates with organic matter, we decided that the chemical methylation takes place in this territory. This situation is mentioned in the literature.
Okay, thank you very much. There are obviously no more questions, so let's thank the speaker again.